Miss Angel.
Hello everyone. Today my group will be presenting our project titled Page Replacement Algorithm Simulator. But before that, let me introduce my group member, which is Haris Hashim, Nuha Imani, Sarah Irina, and Angel Tay. This project focused on implementing three algorithms, which is FIFO, LRU, and Optimal, by using C++ programming language. These algorithms are part of memory managing in operating system, where they help decide which place to replace when the memory is full. The main goal is to reduce page faults and improvement system performance. FIFO replaced the older page, LRU replaced the least recent used page, and Optimal replaced the page that will not be used for longest time in the future. Next. In a computer system, the main memory was limited space, also known as frames. When a program requests a page that's not in the memory, a page faults occur. The operating system must then decide which existing page to replace in order to load the new one. If the wrong page is replaced, it can increase the number of page faults and reduce performance. To test and compare different replacement methods, our project used a reference string with 20 page requests and 4 memory frames. Next. The main objective of our project are, first, the simulate three-page replacement algorithm, which is FIFO, LRU, and optimal algorithms. Second, to display and observe how pages are loaded and replaced in memory. Third, to calculate the number of page hits and page faults for each algorithm. And lastly, to compare their performance and determine which algorithm works the best.
Okay, so thank you, Angel. So I will continue the slide. So let's talk about the FIFO memory method, which is FIFO is stand for first in and first out. So it's a very simple rule for managing memory. Think of memory like a line of people. So the first person who got in line is the first person to leave. For memory, it means the oldest data is the memory is the first to be removed when the memory is full and we need to add a new data. So it's very easy to use. And now I will show you how it's work with an example. Next. So here we see the FIFO algorithm working step by step. So the number at the top are the pages the computer needs. So the row below show what is the memory at each step. First, page 251 and adds into the empty memory. When the page 2 comes again, it's already in memory, so it's a hit. Nothing changes. So the next new page is 3. The memory is full, so we remove the older page, which is 2, and add 3. Next, we need a page 4. The order page now is 5. So we remove 5 and add 4. So this process will be continuous, and you can see the order page is always the one that gets the replace from the top row. So let's look the final result, which is total page 4 is 16. This means 16 times the data was not in memory. And then total page hits 4. Only 4 times the data was found in memory. And then page 4 rate is 18%. So 18% of the time the computer had a slow problem. And then the last one, the patch sheets rate is 20%. Only that which is not very good. So this show that while FIFO is simple, it cause many problems that for computer speeds. So I will show the coding and the output. So here are our codings, which is FIFO methods, and then I will try to run. Okay, so here the output. So this all from me. So I will pass to Nuha.
Okay, so thank you, Sarah. So I will be presenting the least recently used or LRU, the page replacement algorithm. So LRU is the algorithm that is designed to minimize page faults by keeping track of page usage history. So it works based on the principle that pages used recently are more likely to be used again soon, and the pages that haven't been used for the longest time are replaced first. So next slide, Haris. So here we have a reference string which is 25128 534 to 573 to 862 and 3574. So as the algorithm runs, the pages are loaded into the frames as shown in the diagram. So each time a new page that is not in memory is needed, a page fault occurs and the least recently used page is replaced. So after completing the process, we can observe that the total page faults are 14, total page hits are 6. And then the page fault rate is 70% and page hit rate is 30%. So this shows that while the LRU algorithm efficiently tracks usage patterns, page faults still occur when new or orally used page are requested. So overall, LRU performs better than the simpler methods like FIFO because it uses recent usage information to make smarter replacement decision. So that's all from me for the slide. So we will go to the demonstration of LRU. So this is the coding of LRU. So when we run it, so enter number of frames, which is 4. Number of pages, 20. And then we have 2, 5, 1, 2.
Nak enter ke dia je?
Apa dia?
Yang ni kan apa? Ni nak tekan, ni biarkan 2 lepas tu 5 terus ke tekan enter?
Oh, just tekan 2, jarak 5.
Okay.
Boleh tak?
Boleh.
1, 2, 8, 5, 3, 4, 2, 5, 7, 3, 2, 8, 6, 2, 3, 5, 7, 4. So this is the result, which is it tells you the page faults and the page hits, where the page faults is 14 and the page hits is 6. So that's all from me for the LRU. I will pass to Haris for the optimal.
Right, thank you Noha. So let's look at another algorithm, which is the optimal algorithm. So what is the optimal algorithm? Easily said, the optimal algorithm is an algorithm that aims to replace pages that will not be used for the longest time. The steps for this algorithm are simple. For every reference page, first, if the referred page is already present, we increment the heap count. However, if it's not present, find if a page that is never referenced in future. If such a page exists, replace this page with new page. If no such page exists, find a page that is referenced farther in the future. Replace this page with new page. So in layman terms, when we have the layout for the frames and the reference string, we have to find, let's say our reference string has numbers, right? We have to find the numbers that will not be used for the longest time. I think it will be more clear if we show our demo here. So this is our result based on our strings. So for the demo, let me show you. So here, so we have 4 frames here that will be just placed as usual. So our frames will be 2, 5, 1, 8. So here we see 3. 3 is, however, not in the frames. So how do we determine which place to replace it? So we look the most furthest to the right. So let's look at 2. 2 will be used in another 2 tens. How about 5? 5 will be used in another 4 tens. 1, as we can see here, 1 will not be used. That means will not be used in the future. And 8, however, will also be used in the future. So this is why we replace 3 with 1, because it is the furthest from the one to use. Alright. So based on this, we got 11 total page faults, 9 page hit, and our fault rate is at 55 and hit rate at 45. So let me show the coding. Right, so here is my coding for the optimal page replacement. There are some functions. This one to find the page to be replaced, this one to declare page and number of frames, and this one is to display the result. So let's take a look at the results. Right. So here our coding shows a step-by-step simulation, which is the same as what was shown on the slides. So as you can see, 11 page faults, 9 page hits, 45% hit ratio, and 55% fault ratio. Right, next up, let's look at our analysis. Right, so this is our analysis. So for FIFO, LRU and Optimal, our three algorithms, we compare based on page fault, page hits, hit ratio, and fault ratio. So for FIFO, we have 16 page faults, LRU 14 and Optimal 11. Optimal is the least number of page fault, and also Optimal has the highest number of page hits with 9, LRU the middle with 6, and FIFO with 4. Hit ratio, FIFO the smallest with 20%, LRU the smallest with 30, and Optimal the highest with 45. While fault ratio, FIFO is the highest with 80, LRU the middle with 70, and Optimal the lowest with 55. So next. So, as you can see, the best algorithm should have these four things, which is the highest page hit, highest hit rate, lowest page fault, and the lowest page ratio. Excuse the typo there. Therefore, the best algorithm based on this analysis will be Optimal. So I will next pass to Angel for the conclusion.
To conclude, our project successfully simulated the FIFO, LRU, and Optimal algorithms. From our result, the Optimal algorithm gave the best performance with the fewest page faults. The LRU algorithm also performed well and is more practical for real systems. Meanwhile, the FIFO algorithm was the simplest but had more page faults. Overall, this project helped us better understand how operating systems manage memory efficiently using page replacement techniques. So that's all from our group. Thank you.
Thank you.